Your refrigerator. What would you do without it? You go to it every day for cold drinks, healthy snacks, and some not so healthy, whatever you feel like making. But who makes your refrigerator? And how do they make it? Turns out it's a pretty amazing process. Welcome to Appliance Park in Louisville, Kentucky, home to GE Appliances, a hire company. This place is huge, 900 acres huge. Each one of our manufacturing buildings could hold 15 football fields. That's 90 football fields of factory space. We even have our very own zip code. Welcome to 40225. Right now, you and students all over the Louisville area are about to start your virtual field trip. Are you ready? Here at Appliance Park, we make some of the world's best refrigerators, washers, dryers, dishwashers, and more. What makes them the best? Our people. Whether it's design, engineering, manufacturing, maintenance, or service, there are thousands of people here with really cool jobs doing really cool things every day. Maybe it's something you'll want to be a part of someday. I know it was for me. Hi, I'm Lauren. I'm a quality leader here at Appliance Park. When I was in high school, I really wanted to get involved in engineering because I wanted to help people. And here at Appliance Park, I'm able to help people every day, whether it's helping operators on the line to make their jobs easier or making our factories more efficient. So first, we're going to start out in the Manufacturing Training Center, where you'll build and develop your skills. Next, we're going to head over to the Rapid Prototyping Center, where we'll see some amazing 3D printers. Finally, we're going to wrap it up by going down to AP5, which is our refrigerator factory, where we're going to see some of the best refrigerators in the world being made. If you guys are ready, let's go. When you get hired to build refrigerators here at Appliance Park, or for any production job, you're going to start off at the Manufacturing Training Center. Let's check it out. So it's kind of like a training camp. It's a place where you can come to learn and develop your skills before you go out on the production line. So let's go meet Ashton, and she can tell us more about the Manufacturing Training Center and the mock line.
Thanks for coming to see us in the training center. So as you know, this is our Manufacturing Training Center, and what we do here is pretty cool. So whether you're coming in to work on production lines or you're an engineer, we've got a class for you. And what's going on behind me, all this action, is actually our mock line. So it's for our new production assembly workers. Whenever they come in, the first day on the job, we want to get them comfortable with the type of things they're going to be doing on the plant floor. So they're shooting screws, they're practicing material flow and delivering parts to the line. So it's a pretty active day for them. And behind me right here is actually one of our simulators. So this is for some of our more mid-skilled jobs, like a maintenance technician. This is actually a hydraulic and a pneumatic simulator. A lot of our equipment on the floor uses this type of technology, so we have to train a lot of our folks coming into those jobs on how to do it. So all different types of jobs, all different types of classes happen here.
That sounds great.
So these guys just started today, so it's their first day on the job. So they're learning how to do everything from delivering parts to putting a box over a dishwasher to learning how to shoot screws with different types of air guns. So it's a busy day for them. They get a little sweaty.
Lauren, are you ready to see our robot?
Yeah, let's go see it.
Okay. It's right over here. It's really awesome. All right, so Lauren, I'd like to introduce you to ALIZA. She's one of our AMT students, and right now she's working with one of our robots, and we call it Little Fanic.
Can you tell us a little bit about how robots are used in manufacturing?
Sure, in manufacturing, they kind of help speed along the process and put components together, like in our refrigeration plant.
That's awesome. You know, a lot of people think robots can take our jobs away, but actually they make our jobs a lot cooler.
So I grew up with my grandparents, and my grandma always pushed me to go to a four-year college and become a doctor or a lawyer because I did really well in school. I always got straight A's. And then whenever I got into high school, I took an Introduction to Manufacturing Processes class, and it opened up a whole new world for me. I really liked manufacturing. I really liked working with my hands and learning something new every day. So then my high school guidance counselor called me about the Kentucky FAME program, and then I was sold. Because at this point I was living on my own, I needed to support myself, and this was a way that I could go to school debt-free while getting paid, coming to work, always doing something new and interesting. I applied for the Kentucky FAME program and didn't think I was going to get in. And then I got the phone call, I got into the program, and now there's just so many options that I can take. The opportunities are endless.
Thank you so much, Ashton. I learned so much being in the Manufacturing Training Center today, and I got to see how cool manufacturing can be.
It really is. I'm so glad you came. Have a good day, Lauren.
Yeah, you too. Bye, Ashton. Bye, Little Fanic. In the Manufacturing Training Center, people get ready for their jobs on the production line. But what about our components, tools, and processes that also have to be ready? We're about to find out. You've probably heard of 3D printers before. Maybe you've even seen or used one before. But I bet you've never seen any quite like these. Welcome to GE Appliance's Rapid Prototyping Center, home to an all-star lineup of amazing 3D printers. Hey guys, what is this?
That's a ball. We made it here.
Yeah, we printed it.
You guys do work here, right?
Kind of.
We'll explain. Hello, I'm Raphael Sands. I'm an Edison here at GE Appliances. I've been here for over 2 years. I currently work in laundry doing test fixture development and qualifying our washers for high-speed spins.
Hi, and I'm Bo. I'm also in the engineering development program here at GE Appliances. I work at First Build, which is a micro factory at the University of Louisville, to engage the community in our design creations. I currently work on connected cooking. So one of the first things I think we should talk about the RPC is going over how the iteration process has changed since we've had this facility. So before, when we didn't have the RPC, we would go through a couple of stages before we came up with a final product. But the problem is if we found issues with that design, we wouldn't be able to fix them in time for production.
Thanks to rapid prototyping, we can create different shapes and sizes to fit our purpose overnight, so that we can try several iterations until we get it just right, saving us a lot of time and a lot of money.
Let's go check out some of the cool printers we have here. So this printer right here is the PolyJet. The cool thing about the PolyJet process is it takes liquid plastic to pump into the head of a nozzle that deposits on top of the part. It then uses a UV light to cure that plastic and make it hard. One of the neat things about this printer is it has multiple materials, some of which are even flexible. Cool thing about this is we can take that flexible material and combine it with hard plastics to create really cool prototypes, such as this part. It uses a rubber flexible part for a gasket and the hard plastic piece to form the rest of the plastic part.
Hey, Bo. What are you up to?
Hey, Raphael. I'm just here playing with our stereolithography machine.
Oh, cool. How's this one work compared to the others?
Well, this one's really neat. What it does is it takes the part and it dips it into a pool of liquid plastic. Then a laser runs over it and hardens the plastic wherever the laser hits. This one's really old. It was invented in the 1980s. It was actually one of the first 3D printing technologies. Actually, I have a part right now. You want to check it out?
Yeah. That is pretty cool. Should we check out some other machines? Maybe the SLS?
Yeah, but me first.
Let's take a look at our SLS printer, which stands for Selective Laser Sintering. The way this one works is you start off with just a layer of plastic powder. You heat it up to just below its melting point, and you come in with a laser, and you only dry or harden the portions you like. Then you come in with another layer of powder, and you repeat. This screen shows us the current layer it is printing. Right now it doesn't look like much. You cut anything in half, you don't see a lot. But as you stack them all up, you can get very complex features. Oh, do you mind explaining to us what that block is?
You mean this pile of sugar? No, I'm just kidding. Do not eat this. It tastes terrible. But this right here is the powder that comes out of that process. What's really cool about it is the parts are embedded inside of this block. So we're going to dig for it, almost like digging for dinosaur bones. So let's see what we can find in this excavation. That was pretty cool, right? Now let's go check back in with Lauren.
Hey, Lauren.
Hey, thank you guys so much for showing us around the Rapid Prototyping Center today.
No problem.
Can I have your ball back? You guys get back to work. Before we head over to the refrigerator factory, let me ask you something. Have you ever thought about the way a refrigerator sounds? We're about to meet some people who think about that every day.
Hi.
Hi, Avi. How are you today?
Good, how are you?
Good. Can you tell us a little bit about what you do here in the acoustics lab?
Sure. So this is the acoustics lab area, and what we have is 3 chambers, and I would like to show you reverberation chamber first.
Cool.
So why don't we go in?
All right. It's a huge door.
Sure. So now, as we come in this room, what you may notice is that this is first of all a big room. It is pretty tall. And let me show you what this room is all about. So let me clap. So what you notice is that the sound is going on the walls and is reflecting back. So this is what we call reverberation. The sound is reverberating. So reverberation of sound is what the purpose of this room is. Typically, we'll keep our units like refrigerator or dishwasher. We keep it in this area, and they'll be operating. So imagine them like a source of sound, right? So clapping was a source of sound in my hands. The same way refrigerators are source of sound. So the way we measure sound is with microphone, and as you can see here, this is a microphone stand and it is rotating. So what it is doing is, it is measuring sound at every second as it rotates. So it typically takes 32 seconds for one rotation, and so we take the average. And the purpose of this room, once we get the number, then the question is it quiet? And if it is not, what do we do? So we do a lot of engineering here. We try different designs and modify it. So when they are in your kitchen, they will not be loud. So this is reverberation chamber. Now you will be amazed as you go in the other room, you see the difference between that room and this room. So let me do the same trick here that I did in the other room. What you notice is there is no echo, there is no reflection. So what is happening in this room is, as the sound goes out from the source, it hits walls, and as you can see here, these walls are not your regular walls. There are a lot of wedges and they are pretty deep. So what happens, sound goes inside, it reflects back and forth, and all the way as it reaches the end, sound is all absorbed. And we are not used to hearing that, So if you stay in this room very, very quiet for like few minutes, you will hear your own heartbeat.
Really?
And you will feel pressure in your ears. So it's a special room. We want to find out if a certain appliance is loud or not loud, and we want to know why it is loud. Is it pump? Is it fan? Is it something else, water splashing? So we do that investigation and we root cause it. That is where science comes into picture, is how do we use science to make real life appliances better. So it's pretty cool room, and it does quite a lot for us for designing appliances.
So now we're heading someplace a whole lot louder. We're gonna head down to the refrigerator factory and see Maurice and some other great people that work there. So come on. Welcome to Building 5. This is where we make some of the world's best refrigerators. Let's go inside and check it out.
I'm Maurice Staller, one of the business leaders here for Plastic Systems and Support Areas. So I'll be giving you a tour of how a refrigerator is made. Let's get to it. Okay, everybody, just remember, safety first. Plants can be a fun place, but you always want to wear your PPE and be mindful of mobile equipment. So, eyeglasses on, let's head out. Welcome to Plastics. This is where a lot of the magic happens. Come over here, I'll show you some cool stuff. So Plastics, this is what we call thermoforming. This is where we take a plastic sheet, heat it up, and form it into all kind of cool things. So you know your normal refrigerator, the inside of the refrigerator, you see all the white parts that your shelving slides into, that's known as your liner. Here's where your liner is made. So it starts out as a normal plain flat white sheet in our load station. From there it's picked up, follow me. Taken into what we call our preheat station. Our preheat station takes and starts to warm the sheet just to get it conditioned so it can be ready for form. From there, it moves into our main heat. Our main heat has over 300 heaters on the top and the bottom, which help heat the sheet up and make it ready to change shape. From there, it transfers into what's called our forming station. Here we have a mold shaped like the exact shape of the inside of your refrigerator. So there's the mold. That tip of plastic actually wraps around the mold and takes that shape. Once it's done here, you'll see it exits out there. So you have what started as a nice flat sheet, now shaped like the complete inside of your refrigerator. We trim out those extra edges, and there you have it, a finished liner. From there, the liners come down a conveyor. You see our controlman check and make sure they're making good product, and goes down the line. Okay guys, so now you've seen the finished liner. Now I'm going to take you over to trim and pierce where we get it ready for assembly. Follow me. Okay guys, here we are at trim and pierce. We take each liner and it goes through a piercing station with a series of rams cycling. What that does, it puts all the holes for all the assembly parts you need on your refrigerator are put in here. So your LEDs that go on the side, your freezer light switch that shuts your freezer on and off when you open and close your door, all those holes for those parts are put on here. Okay guys, this next area is what we call panelization. So you'll see what was the liner that was getting all the parts assembled on it now start to really take shape and look like a refrigerator. This first station will put the top panel on, the next station puts on the two sides. So now you've got a refrigerator with the top, two sides. As it continues down the line, they'll put on the bottom and the back, and you have your finished outer shell of the refrigerator. Okay everyone, now we're at the beginning of the foaming process. We'll take that finished case you saw being built on case line, and now it's going into the foam process. Here you see our large Fanuc robot. You may have seen the little Fanuc earlier today. It'll take each of the cases, pick it up and load it into a foam fixture. The foam fixture is used to help the case hold its shape while going through the foaming process. Here you see the big Fanuc work. Maria is one of our team leaders in Steel Systems. You're kind of an expert in this here. So could you tell us what's going on in this process?
Over here we have Frank, who is brazing a copper to steel joint. He is brazing the joint to the condenser, and the condenser helps the refrigerator to run. Frank enjoys the flame brazing, I think, more than anything else. And I enjoy the flame brazing myself. So
Brazing is kind of like welding, is it not?
yes, it is, but there's a difference in the material.
What's the coolest part about being a flame brazier?
You get to play with fire all day. Only thing about it is just in the summertime it gets a little hot, but it's like you get to play with fire.
Okay guys, after walking through all those processes from thermoforming to trim and pierce to assembly, braze and foam, in just under 6 hours you've got a finished refrigerator headed out the door to each of your homes. Everyone, Blake is one of our Kentucky Fame maintenance apprentices. So what would you think is one of the best things about being in the Kentucky Fame program?
I think the best thing is being able to go to school and be able to work in a factory at the same time and get the work experience. I've always worked with my hands. I've always wanted to fabricate things, build things, make things myself. So when I was a kid, I was always working with my dad, and we always were fixing things. We bought a lake house. There was a lot of work needed to be done. We ended up working and fixing it up completely. I learned a whole lot from that, but I also gained interest in it. And through this program, I was able to take those skills and apply them to this job.
Thank you, Maurice, for that great tour of our refrigerator factory.
It was a pleasure.
If there's any kids out there that are interested in manufacturing careers, what advice would you give them?
I would say there's several different types of jobs here. So I'd say it's really about learning what you're good at and nurturing it from there.
That's awesome. Thank you so much.
Thank you.
Have a great day.
You too.
So we're getting ready to head over to question and answer session in Monogram Hall. Get thinking of questions, and we're going to head over there right now. See ya. Hi everyone, welcome to Monogram Hall. The team's all here and ready to answer your questions. Let's get started. All right, our first question's for Maurice. How much training is needed to operate the robot?
Training, that's actually a very good question. So there are several different answers to that question. So if you wanted to be one of the engineers initially programming the robots, that's typically done by our controls engineer who have electrical engineering degrees who've gone to college. But also within our maintenance team, we have several techs who go through several different iterations of training, ranging from 1 day to I estimate a week long, just to learn the controls and how to operate the robot and reprogram some of the simpler moves.
Awesome, thank you. All right, now we have a question from Rihanna at Carruthers. Is also from Maurice. How many refrigerators do you make a day?
That's also a good question, Rihanna. We make approximately 12 to 1,500 refrigerators per day.
That's amazing. All right. This is from Kelsey for me. What opportunities do you have to advance to a management position? So there's a lot of different ways that you can advance to a management position. Some people start out as just production workers and then they work their way into a salary position. And some people come in as engineers and start that way and then work their way up. But as long as you have, you develop yourself and your leadership skills, there's definitely many paths that you can take to get into a management position. So. All right, this question is from Anthony at Mount Washington Middle School. This is also for Maurice. What is the highest level at GE Appliances and how do I prepare for a job there?
Highest level. So, essentially if you're looking for a management position, we have our CEO. And from there you have several different iterations of management down to a individual plant manager at each manufacturing facility. Also within operations, we have several different level jobs that range from level 1 jobs up to level 7s. As far as preparing yourself for the job, again, it's kind of like I said during the tour. It's about finding out what you're good at and make sure you nurture those skills. So if it's problem solving, whether it's working well with your hands, whatever that is, taking that and really pursuing that and getting good at it and then having a good work ethic.
Awesome. Our next question is from Caleb at Farnsley, and this is for Bo. How do 3D printers know where to cut, and how precise are they?
Well, cutting, it depends on the process, whether or not you need to cut them, but they can be really precise, down to 1/1000th of an inch. Depending on what the technology is, you have different advantages between each, but they can make some really cool parts, and there's just a lot of different things you can do with them.
Cool. All right. This is for ALIZA. Are you planning to get a 4-year degree someday?
I do plan to go back to school and get a 4-year degree. I haven't decided what path I want to take, either engineering or business yet, but there's many options that I can decide to take if I want to.
Okay. This is a question from Mount Washington, and this is for Raphael. Any idea how much the 3D printers cost?
A lot of allowances. Depending on what kind of 3D printer you're looking for, you've got maker bots you can buy for your house. Those run roughly $1,000. When you're talking about 3D printers we have here and their capabilities, it could cost as much as a car or more.
Cool. This is for Ashton. How hard is it to get a production job at GE Appliances?
So I wouldn't say it's hard. I would say there are some process steps you have to take to get a job at GE Appliances. Now, if you're talking about working in production assembly, we're looking for people that are coming, in a lot of our students' cases, out of high school. And we're looking for certification or maybe some experience in manufacturing. So we really like to hire people into assembly jobs with the Certified Production Technician credential, or it's called CPT. And we partner with the Kentucky Manufacturing Career Center to get people that certification so they're better prepared to come work for us. Otherwise, we look for different levels of education. If you look at your career brochure that you have in your boxes in the school, you'll see the different types of education that are needed for some of our jobs that were highlighted in our virtual tour today.
Awesome. This next one is for Blake. What's your favorite part of your day?
My favorite part of the day, I would say, would be fabricating parts, whether it's welding or machining a part out for the line, and troubleshooting machines.
Awesome. All right, this one is for Avi. If I want to work in an acoustics lab, what should I study in school?
Well, if you want to work in acoustics, in school you may want to take classes in physics mostly, and you want to learn how things move, how they vibrate. So any classes you take and try to work hands-on, get some experience, and that will prepare you for work in acoustics.
Great. All right, this is for Eliza. What's the hardest part of your job?
Whenever you go out to the line and you're trying to troubleshoot a problem, you have to think on your feet and kind of be fast in finding a solution. So that's one of the hardest parts.
Okay. This is for Bo. Have you ever invented anything?
Okay, so one claim to fame I have is I have a patent in my name. That was really exciting. I got to do that when I was a co-op here. I was still an undergraduate at Florida. Came here for a summer to work, and I got to get that in dishwashers. So you can look it up. It's online, freely available. You can see what I invented.
That's awesome. All right. Okay. All right. This is a question from Daniel at Thomas Jefferson, and this question's for me. What happens if you mess up in your job, and have I ever messed up? Okay, so yes, I have messed up. I'm not perfect. I think the best part about working here is you learn from those mistakes, right? And as long as you learn and grow, there's a lot of people that are willing to help and coach you and let you know that you did mess up and how you can do better next time. And I think that's where I've learned the most, is actually from when I have made mistakes and my managers or other coworkers have helped me and told me, and it's helped me. All right, Raphael, how much schooling do you need to do what you do?
What I do? Well, engineers come in with different amounts of schooling. You can come in with a master's or a PhD. Normally a bachelor's degree is enough to kind of get you started, but I highly recommend, if you're thinking about engineering or going that route, ask yourself some basic questions. How much do I like math? How much do I like physics? And how much do I care about how things work? Because that is what you do every day. And I love it, but it's not necessarily for everybody.
Okay. Avi, do you need to have superpower hearing to do your job?
Not really. I mean, you can have just simple hearing, but as you work in acoustics and you hear different sounds, you automatically develop kind of habit of categorizing sounds, different types of sounds, and some annoying sounds or pleasant sounds. So eventually, as you work long many years, you try to learn different types of sound, and that kind of helps you appreciate sounds. But no, you don't have to have super hearing.
All right. Maurice, how did you get to be a supervisor, and how long does it take?
That's a very good question. There's several different paths you can take to getting into whether a supervisor or manager role. Me particularly, I did co-op here at GEA Appliances while in college, then actually went and worked elsewhere and then returned to the company and started working there. But you could definitely get an entry level or a supervisor role coming out of college once you have your bachelor's degree, or from even working kind of up through the ranks from the floor, demonstrating a good prowess for your people skills and problem solving and leadership ability. You could also get promoted from within.
Great. All right, this anybody can answer. So does GE make the robots, or do we purchase them? Who wants to answer?
So I can answer that. We actually partner with robot manufacturers to make sure the robots that we purchase from them do exactly what we need them to do in our factory. So if we need them to pick up a refrigerator case like you saw in the video, we're going to work closely with that robot manufacturer to make sure it does exactly that.
On the design side, actually, too, you've got your manufacturing needs. We'll make much simpler robots to test components over life, something that measures something and moves something and repeats it. An example related to what you saw in the video is your refrigerator doors. We have simple robots in there that just slam your doors repeatedly to make sure when you slam it, the door doesn't fall off.
Cool. Is it hard to work with the robots?
Yes.
Yes.
A mind of their own.
Yeah.
They have a mind of their own.
It's not iRobot bad, but it's involved.
Okay.
Yeah.
All right. Not sure if we have any more questions. So.
I don't know, Maurice, I know there are a lot of robotics in the refrigeration facility. Maybe you would have some insight there.
There's several. My experience, I actually say it's, again, and I grew up kind of always wanting to be an engineer, so I worked with robotics all the way through middle school, all the way through college. I actually find it exciting. I think it's fun. It does take some training to really understand how they work and be to think in the sequential steps, but I found it very exciting, and I don't think it's too overly difficult once you've gone through the proper training.
All right. So this is from Brandon at Mount Washington, and this is for Avi. How did you choose this job?
Well, since I was a kid, I always wanted to learn how machines work, how they interact, and that is how I started. So I have a degree in mechanical engineering. And then I developed interest in vibrations, how structures vibrate, the bridges. And then from that, I developed interest in how air vibrates, which is sound. So it has been a journey, or following your interest. So the key is you have to follow your interest and study science and keep applying it.
Awesome. This is from Nihal at Farnsley. How did you come up with the robot's name?
So we call our robots Little Fanic and Big Fanic because Fanic is actually our partner company that we purchase robots from and work on the design with. So in our training center, we actually have the Little Fanic, and we use that to prepare people to go out and work with Big Fanic. So once you graduate from Little Fanic, you're allowed to go work on Big Fanic.
All right. So this is for both Bo and Raphael. What is the coolest thing that you've ever 3D printed?
Go for it.
So I got a couple things. One was I got to print a ergo tool to help people put connectors on to make their job a little bit easier on the line. That was really cool because it was helping someone out, making their job easier. And it was cool to iterate through trying to fit something to someone's hand. Usually we measure parts and we have measurements we're trying to hit and fit it in a square. But people's hands are all different, so it was really interesting. I got to use the PolyJet that we went over in the video to put a soft rubber part by their thumb and then have a hard plastic part to let them push the connector on. And then the second thing is at First Build, we're actually launching an accessory to the Paragon, which is a product we have that we launched a year ago. And in that accessory, we have actually a couple of 3D printed parts that are going to be put into the product, which is something unique that doesn't happen all the time, but it's pretty cool that we're getting to apply it that way.
On my side, we just came out with a dishwasher with a silverware blaster. And in order to test that and ensure that our jets had the right pressure aiming the right direction, I printed several different iterations on 3D printers to prove out that it worked, and it came out quite successful.
Great. So thank you guys so much for attending and for asking some great questions today. We really enjoyed having you guys, and hopefully you learned a lot and you're excited about manufacturing. So thanks.
Yeah. Bye.
Bye.